Morning, one and all. This is Coach Jay. It is Friday at 11:15. This is what I do on a Friday night. Math, and I'm actually watching some basketball right now. It's good times. I love it. Absolutely love my job. I love y'all. Hey, I know I didn't post a podcast for the section, largely because I forgot in class. I know we had a crazy week. Specifically on Friday and block day, I got kind of carried away. We had just kind of a lot to do. So I wanted to post a podcast for you as we prepared for the quiz. And so check this out. This is over section 11.2. Understand also 11.1 includes a lot of this stuff as well, or is included within the quiz. So just be sure to kind of have that so that you're able to access it there. The big thing is you want to make sure you understand it before you come in with that quiz. And if you have questions, come on in Monday morning. Before I think it's 11:40, I have a meeting, and I'll shoot out a Remind 101 on that as well. Okay. All right. So without further ado, I'm going to kind of hit on these quickly. I'm not going to spend too much time on any one problem, largely because I'm assuming that we've already have some exposure to what we've already done. All right. So first thing we want to address is this idea of arithmetic sequences. We've talked about sequences already in section 8.1. And once we talked about it in 8.1, we talked specifically about all types of sequences. Well, now we move towards more of a specific type of sequence. And in this context, we're going to look at this idea of arithmetic sequence. And I'm actually going to make sure that this is all fired up there. Sorry about that. There we go. Okay, so sorry about this. Let me backtrack. All right, so let's say for some reason we look at one and we look at a sequence of 2, 4, 6, and 8. We address the situation where if we either added by a specific number or even subtracted by a specific number, and we would call this an arithmetic sequence. And we would call the number that we would either add or subtract to get to the next, we call that the common difference, right? Well, this idea of this is brought in to word problems, which is at the end of section 8.2b homework that has 3 or 4 specific problems where it's addressing how to find the sum of specific sequence. And we'll get to that here in a second. But just a heads up, if we say that the first row of the Vision Showcase show, which is coming up soon, is 20 seats. This addresses the fact that A1 or and A1, this is a big deal. A1 represents my first term, okay? So the first term is the first row in this context, and we would say that that would be 20. Now, since it increases by 4 each time, we would say that 4 would address this idea of my common difference, because every time if I increase this by 4 each time, we would say the difference would be positive 4. Now, as we keep going, another thing we remember is that whatever the total amount of numbers in the sequence is, in this case, there's 25 rows. So we would say that n would be equal to 25, meaning that there are 25 numbers in the sequence that we're going to add together. So with that being in mind, we have this equation, which, by the way, I kind of eliminate the left side and use more of the right side here, to where if I said to come up with an equation, you should be able to figure out what the equation would be on this other one by saying a sub n is equal to a1 plus n minus 1 times d. Now, if I were to plug this in, based on the context of this problem, a1 being 20, n being just simply n, we're not really sure what we're going to use yet. And I'll show you. We will plug in 25 here technically. D would be positive 4, and a sub n here, where this yellow equation would represent the equation of any row within this theater. So if I said, how many seats are in the 10th row, if I did the equation appropriately, which I did, I could plug 10 in for n, representing the 10th row, and I could figure out how many seats are in there. So, and then actually, technically, we should be able to multiply this by 4 on each side to get the following. You would be able to get, and I'll erase this here. I'll say 20 plus n minus 1 times 4. But I could multiply 4 across to get 4n minus 4 20 plus this to get 4n, and then plus 16, and this equals a sub n. Cool. And that would be the equation that we would get there. So just again, a heads up on that and how I would attack this. If I wanted to find what the 25th row is, not the sum of it, that's different. But if I found what the 25th row is, I'd plug 25 in for n. And so I would get a sub 25, which means this is the 25th term of the sequence is equal to 4 times 25 plus 16. So this would be 100 plus 16, which would be 116. So 116 is the 25th term of the sequence. Cool. All right. Another idea, and I think we were pretty good on this, just kind of have an idea of what is an arithmetic sequence. Well, remember that just means we have a common difference, right? We represent that as a D, and I think y'all are good on that. This is either like adding or subtracting by a common number. One example that would not be is like number 4. Notice we're multiplying that by, I think it's 2 each time, right? On the top. And if we multiply that, that moves more into our next section on 8.3, multiplying and dividing. Okay. So just again, a heads up on that. Wanted you to be aware of what was going on that number. All right. Number 9 is another good one. Just as a heads up of what we would be doing to attack this here. The question becomes, right, the first 5 terms of the sequence. And let's do a different one just to show you the difference here. So if like I did number 14, where I said 2 to the n minus 1, and I said write the first 5 terms, I'd plug 1 in for n. And when I did that, my first term would be 2 to the 0 power, which is 1. I then plug in 2, so 2 to the first power would be 2. I plug 3 in, which would be 2 to the second power, which would be 4. And as you notice really quickly, this would keep going to 8 and so on and so forth. But what's happening is I'm multiplying by 2 each time, and there's not really a common difference. So without a common difference, we would say this is not arithmetic. So it's not arithmetic because we multiply by 2 each time, and therefore you would not have to come up with an equation. Now, let's say we did have an equation, like I know number 9 is a good example, or number 13. If you find what the common difference is in A1 is, similar to the problem we did in the Vision Showcase, we would plug in what A1 is, plug in what our difference is, and then simplify the equation to find what we would be getting out there. Okay. Now, another thing that some people were bringing up was, and I love Jay, actually, I want to give a little shout out to Jay. He rocked it in class today because mainly he just thought of a different way of attacking it, different way of doing it. And so what I'm going to do is I'm just going to quickly show this and then understand that there is a way of doing like number 25 and 26, such as like 26, you could do it in such a way where you did it with the equation where it's A1 plus n minus 1 times D, right? And you could do this for 2 different equations where the 5th term would be in 190, right? So we would say, if I was plugging this in, I would say a sub 5 is equal to A1, we don't know what that is, plus 5 is n, right? So 5 minus 1 times D. And a sub 5 is already 190, so we just say 190 is equal to A1 plus 4D. And you could do the same thing for this one, right? And if you kept going, by the way, this one would be, just so you know, so you could kind of see this, 115 equals A1 plus 9D, okay? So what we could do, and again, I'm doing the long way, and then I'm going to do it Jay's way because I liked his way better, really. I could put this one underneath the first one here, so 115 equals A1 plus 9D. I could use elimination by changing the signs here, here, and here. This should be a negative here. That cancels, giving me an answer of 75 is equal to negative 5D. We divide by negative 5, divide by negative 5, where D is equal to, I think it's 15, right? And it would be negative 15. So my common difference is negative 15. You could simply plug it in to get what A1 is. Once I get A1 and my D, I could plug it back into the original equation that we talked about already up here to get what my overall equation would be. But here's what I love about what he did. he said this, Coach, couldn't you do this? Which I thought this was brilliant. He said, couldn't you, if these numbers aren't too far away from a sub 1, which neither and none of these are. He said, if you are given ones like, well, first off, if you had 18, that's basic, right? You would just plug in 15 in for A1, n minus 1 times 4, right? And that equals a sub n. Multiply by 4, simplify, and you're good. But he said, Coach, what if you had this? If you just took this and you said the difference between A5 and A10 is 5 different terms, right? Said, okay, I get you now. And then he said, what if you took 190 and 115 and you did the same thing, and instead you said, okay, I know that I am subtracting, right? So what I'm going to do here is I'm going to say that I'm going to be decreasing, okay? So there's 5 terms. So what I'm going to do is I'm going to take 115 and subtract 190 to show myself that between here there's 5 terms and there's a difference of negative 75. And I said, okay, I'm tracking. And then he said, okay, if there's 5 terms and the difference between the 5 terms is negative 75, simply divide the 5 by negative 75 and you get a difference of negative 15. And I thought, man, that's really good. And then he just said, once you get that, then you can just take, let's say, a sub 5 subtracted by 15 a number of times. In this case, you would do it 4 different times. And once you do that 4 different times, you would subtract then 60. So 4 times negative 15 is negative 60 to get and you would actually add because you're going the opposite way, my fault. And you would get 250 would be A1. So once you do that, you're kind of going backwards almost. And then once you take these 2 terms, you simply plug it into your equation. A sub n equals A1 plus n minus 1 times D, where D is negative 15. You have n minus 1 that you would keep here. You'd have A1, which would be 250 plus, and then this equals A sub n, where A sub n is literally any equation. So we could just multiply this across, negative 15n plus 15. And I said any equation, really this means any term, my fault. So you'd say 250 plus 15 is 265 minus 15n. And once we get that there, that's how we would get our answer, our equation for where we're at. But I thought that was really brilliant because he's just used, I don't want to say common sense, because I thought, I just thought he found a better way. So I really like that. So I hope that helped you as much as it helped me, just to maybe explain it just a little different, a little bit better there. Here's some more ones that you could use too. Just a couple of ideas here. Remember our table function. If you have questions on how to utilize the table, let me know. But there is a way that you could plug in into the Y1, plug those values in, and get out what the first few terms are there. Remember recursively, this idea of recursively means we're simply just plugging in specific values until we get to the designated terms. So like if I did one like number 36, I don't think I did in class, it says write the first 5 terms. So you have a sub 1. Let me do a different color here. All right, so you got a sub 1 here, a sub 2, A3, A4, and A5. And remember that each of the A4s, 5s, it just talks about what that specific term is. So this is the first term. First term is 200, right? Now, in order to go to the second term, we have to plug it into our rule here, which states that whatever a sub k is, in this case, it would be a sub 1, we subtract 10 to get to the next term. Now, that k plus 1, don't let that confuse you. That just means that we're going to hop from A1 when we plug in 200 minus 10. We get 190. 190 equals this just means the next term. So we plug in for a sub 2. To get to a sub 3, we simply plug in 190. We subtract 10 to get to 180, and we go so on and so forth. Okay? Now, once we get these 5 terms, the question becomes, what is the actual equation? Well, we remember the equation again. And again, I don't mean to insult y'all. I know y'all know this. But the difference would be negative 10 times n minus 1. A sub 1 would be 200. and we'll distribute negative 10n plus 10. We have 200 plus this, and so we would have 210 minus 10n, and that would equal a sub n here. And that right there would be the equation that's there. And again, I could take this and say, okay, what's the 200th term? What's the 100th term? And if you did that appropriately, you should be able to, come up with whatever that term would be there. Okay. And that's how you attack it. Again, a lot of these on the bottom you should be able to do. Similar to this equation, I'm looking for the 8th, 7th term. I'm using 42, let's say A1 and A2 to see what is the common difference. Well, if I go from negative 0.7 to negative 13.8 from A1 to A2, right? We can see what that difference is by saying, oh, okay, I'm literally subtracting by 6.1. So the common difference would be negative 6.1, where A1 is negative 0.7. So just again, a couple of ideas here that you might just want to hold on to as you progress forward step by step there. All right, the last thing that I wanted to look at is in large part the summations. The word problems at the end, I'm going to look at that vision showcase one at the beginning. But before I begin that, I do want to make sure that I address this summation. The reason why we use this summation is because a lot of times we have a lot of numbers. This equation allows me in an arithmetic sequence. And again, it's got to be, the key is it's a finite arithmetic sequence. So if I said find the sum of the first 100 terms, as long as it's an arithmetic sequence, then we can use this equation. But let's say it wasn't arithmetic. In that context, we would not be able to use this. Or if I said it's to infinity, right? Obviously, to infinity would be very difficult there. So I would say that only for a finite sequence finite arithmetic sequence can we use this here, okay? All right, so let's say 55. Let's use this as the example. Let's say we're trying to find the sum of the first 10 terms of this arithmetic sequence. Where obviously, as I see it here, a sub 1 is equal to 0.5, right? So we've got that there. N is 10. Remember, the n refers to the amount of terms. Don't confuse that with the n that are in these summations, right? These are different n's. This is what I plug into the equation, the amount of terms that I am combining together. So n is equal to 10. 0.5 is my A1. My a sub n is the same thing as a sub 10 because that's the last term, right? So when we do a sub n, that just means whatever the last term is. And so I'm going to have to solve for what the a sub 10 is. And this is where I can use my formula of a sub 10 is equal to A1 plus n minus 1, which is 10 minus 1 because n is 10, times my difference. I recognize the fact that my A1 is 0.5. I also recognize that 9 is here, and my common difference I already put down, which is always helpful. Well, actually, I didn't. From 0.5 to 1.3, I am adding by 0.8. So my common difference is 0.8. Okay? So 0.8 times 9 is 0.72 plus 0.5 would be 1. Hold up, that'd be 1.22. Is that right? I believe that's right. So 1.22 would be my A10. And so when I plug this formula in, it should look like this. It should say S of n, n being 10. So this is the sum of the first 10 terms is equal to 10 over 2 times 0.5 plus a sub 10 or a sub n would be 1.22. So I combine these two together. 1.72 times 5. 0.72 times 5 would be 8.6. And so the sum of this would be 8.6, some of those first 10 terms there. Cool. Again, the Vision Showcase one, just to kind of wrap that up, this right here, you could also address this as well. Remember too, I could attack it this way because of the fact that we're looking for S of n, remember n was 25, right? Because there's 25 rows, that equals 25 over 2. A sub 1 was 20 for the first row, plus a sub n, remember n was 25 because that's 25 total rows. So 25 times 4 is 100 plus 16 is 116. So we plug this in, and this is how I could find what the sum of the theater is in those 25 rows there. Hey, I appreciate y'all's time. I really do. I know that was quite a bit, but if you needed to skip through it or needed different things, that would be awesome. And care about y'all. Love y'all. We are almost done. We're almost there to spring break. Hold on tight. Stay in there. Let's go. Love y'all. Bye.